This conference will now be recorded.
Hello, everyone, and welcome to the Satellite Book Club seminar series. Brian Gockel here, Office of Observations. Wanted to start us off with our talk today is going to be a deeper look into the split window. Our presenter today is Kris White, Applications Integration Meteorologist from Weather Service Huntsville, WFO Huntsville. Our facilitator today is Bill Schoberg from NOAA's LEO Program Office. A couple of reminders. Sessions being recorded as usual. Q&A will be held after the presentation, and we encourage attendees to post their questions in the chat, and we'll field them through there. Not already done, please mute your microphone and turn off your webcam. And attendees are encouraged to sign in with your full name. And also that way, when you ask a question during the chat, we'll know who you are. We could follow up with you if needed. Kashad's going to drop a link in the chat, not already there. Please click on that. That's a link to the Satellite Book Club presenter facilitator form. And we're always looking for future presenters. Training team can be contacted if you're either in search of training materials or perhaps some new materials should be developed. And Ross Van Til can help with that. Any questions regarding that? Thanks as always to the Office of the Chief Learning Officer, GOZAR, JPSS, and our speaker and facilitators, Kris and Bill. Before we hand the mic over to Kris, just a few words about his background. Kris has served in the role of Applications Integration Meteorologist, a joint position between NWS and NASA Sport in Huntsville since 2011. As an Applications Integration Meteorologist, Kris helps researchers at Sport develop, test, and transition experimental products to NWS forecast operations at collaborative offices across the CONUS and the OCONUS, while also working the occasional rotating shifts as a lead forecaster at NWS Huntsville. Before serving and entering his current role, he served as a lead and journeyman forecaster at Weather Service Huntsville, entering the Weather Service as an intern at Duluth in March of 2006. Kris, welcome back to the Satellite Book Club, and please begin as soon as you're ready.
Okay, well, thanks very much. Appreciate the introduction and all the attendees here. I was approached, though, I don't know, several weeks ago to see about doing some presentation and was kind of waffling kind of back and forth on different things and ended up deciding to talk about this because there's interest in this and the increasing efforts with meso-analysis. I think that the split window could be utilized in a lot of cases. It's not going to answer or solve every sort of problem or challenge that may arise depending on the situation, but something that certainly could be utilized perhaps a little bit more. And so there's a couple times I posted some imagery in one of the meso-analysis chat rooms, and some people were interested in the color curve that I had and how I did that, and followed up with me, and I thought, well, maybe I'll just talk about this today. So here I am. So I think I'm actually just going to turn off, maybe I'll stop sharing my webcam just for bandwidth considerations here. And by the way, I'm hoping you all can hear me. I'm assuming that you do. So anyway, so I'm just going to.
Loud and clear from here, Kris. Thank you.
Okay, great. All right, thank you. Okay, so let's go ahead and dive into this. And so, okay, so the split window product. Some of you are probably very familiar with it. Some of you are probably more familiar with it than I am, and some of you may not be so much. So there could be just a wide range of experiences here. But it's some imagery that I've been looking at for some time, and especially because in my part of the country here in the Tennessee Valley, sometimes finding areas where there might be moisture pooling or there are moisture boundaries can be really difficult. And that's especially the case as we get into the summertime, and the low level environment the moisture environment may be relatively homogeneous, and so you really have to dig pretty deep into the data to see if you can sort of tease out any areas where you might have moisture pooling, thus which may favor convection. Actually, sometimes yes, perhaps sometimes no, or maybe where there are boundaries along which that could either act to cause convection to develop or maybe enhance convection a little bit. And so that's the reason I started looking into this some time ago. Of course, and as I get into this a little bit, the split window is also a part of at least 2 or 3 RGBs out there as well. So, but anyway, so what it is, and just for those that may not be just terribly familiar with this product and how this works, basically. So it takes advantage of these very small brightness temperature differences, and ultimately that's differences in water vapor absorption between the 10.3 and the 12.3 micron bands. And we generally refer to the 10.3 as the clean long wave IR and the 12.3 as the dirty. And the reason we call it dirty is because there is more absorption of water vapor in that band than there is 10.3. So just for example, and this is something I do with new forecasters at the office if I'm going over some satellite imagery with them. I'll just tell them in any sort of differencing product or RGB, if you're not real familiar with it, it's generally a good idea to look at the constituent bands that go into that and look at how they're different and what are they actually observing, and then that may help the RGB or the difference product make a little bit more sense. But if in this case here, if I just kind of toggle back and forth between 10.3 and 12.3, what you'll notice is largely the same, but as I go from 10.3 here to 12.3 here, notice that the 12.3 imagery, it just looks a little hazier. And ultimately, that's because you're looking at slightly colder temperatures overall. And that's due to water vapor absorption. And so you're not seeing as far down into the lower atmosphere as you are with 10.3. And so that, assuming, sort of a standard atmosphere where temperatures are cooling aloft, 12.3, especially during the daytime, you're going to be seeing temperatures that are just a little bit colder than the 10.3 band, okay? So in here, this little cartoon I've created, I think maybe helps to illustrate this. And so in a situation where your near surface moisture is deeper, and that's typically what you're really observing here, is just observing where moisture might be pooling or converging, and thus it's a little bit deeper. The split window difference is going to result in larger values. So say here, and this is kind of a cartoonish example on the left here, notice that I've kind of characterized moisture here with this green shading, and you have temperatures at the surface, let's say they're about 20 C, and up aloft where your moisture kind of ends, it's around 10 C, or maybe it ends at least with respect to what's going to be observed in these bands. Your temperature difference is larger, say, and on the right here, where you have a situation where your moisture is more shallow, your temperature difference is going to be less. And so at least in these cases where you have larger values in the split window temperature difference, that would indicate deeper moisture than in a situation where it's more shallow. Okay, so hopefully that kind of makes some sense to some people who may not be very familiar with this. Okay. Seem to have trouble going to the next slide. Not sure why here. It's the pointer. Yeah, there we go. Okay. So so this is a split window product, and this is a default color map if you were to open this up in AWIPS under the satellite menu, the band differences section of that. But forecasters do have the opportunity to create color maps that might be more intuitive for their liking. I would say that I don't show here, and actually we don't yet have the latest RPM install, which has the new grayscale for the split window product. So this was the older default one, the colorized version of it. But I wanted to come up with my own that was just at least more intuitive for my eyes and myself, and just my general thinking about how to apply this product. So now this is what it looks like. Okay, if you just were to look at the split window imagery, and lower values are going to be drier, low-level conditions, or at least areas where my moisture might be more shallow. High values, moisture, or maybe deeper low-level moisture conditions. And then what you see here, well, this would seem to be, well, very shallow moisture, but of course that's actually not the case here. So what you're looking at are clouds and relatively thick clouds where there are very, very small differences between the 10.3 and 12.3 micron bands. So what should you do about this? Well, and I think that Bill Line, I think it was a couple of weeks ago in his talk, he did go over some imagery with a split window, which was really great. And he did mention, of course, the need to provide context for that imagery. So I never, ever, quite honestly, I don't look at the split window without having some sort of other imagery, single band imagery layered on top of it. And it's really important to do that if you want to really understand what you're looking at. You do need that cloud context. And so this is an example image, I'd taken, I guess, several years ago when I'd kind of finally come to a color map that I kind of liked with this imagery. But again, I'm always layering at least the visible, usually the vis red on top of it, but I'm going to show you a few other things that you would want to consider as well. So it is important to layer those clouds so you can distinguish clear sky conditions from cloudy areas, as you see here. So again, I'm going to take you through another one of these cases. So here is if you're just looking at the split window difference by itself, and it'd probably be very difficult to make much out of this scene right here. But then once you layer visible imagery on top of it, well, now it starts to make a little bit more sense. And so the way I've tailored this color map is basically, it's very simple. It goes from brown to green. And greens are simply going to be indicative of areas where you would have relative deeper moisture, and thus brown is relative more shallow moisture areas. Okay, so this was a scene, actually you can tell I put some of this presentation together, a lot of it this week. So here you see a very recent scene here from the southern Mississippi Valley, the Southern Plains here in Texas. So this is just with the visible imagery layered on top. Now, if you want to add more information, and I do commonly do this, I will have also the 10.3 micron band in there, so you get temperature information added on, so you can see cold cloud tops in this case, and where you do actually have perhaps active ongoing convection. And sometimes, if you have very thin cirrus, it may be difficult to distinguish that thin cirrus from areas where you are or where you have low-level moisture that is increased, because the brightness temperature differences in thin cirrus can be rather high. And so sometimes it's not real clear to me if I'm looking at cirrus or if I may be looking at just a clear sky condition. I will often pull up the band 4, the 138 micron, to make sure and see whether or not there is cirrus in that area. And sometimes I may just bring it up fully like this and just kind of toggle back and forth to make sure I'm not looking at cirrus. Say in this area, southwest Texas, along near the Rio Grande, it's fairly obvious here that's cirrus, but I just want to make sure. But there may be other areas like in the western Gulf of Mexico where it may not be so obvious, and I might toggle back and forth to see, well, whether in fact that is cirrus or something. And you can also, and I do have a procedure too, that where I'll just layer this also on top of that and set it to a part transparency. Usually the viz imagery I'll set to about 75 or 80% transparency, and then these other two, the 10.3 and the 138 micron bands, I'll set them to about 25%. It's what works for my eyes, but you might like something different. But that's basically what I've done here. So one of the really important things about this, if when you're doing meso-analysis, if you're really going to kind of dig deep, more quantitatively into the data, and I would highly encourage you to do this when using the split window imagery, whatever color map you might be using, is that brightness temperature values are the differences. They're going to change not only from area to area, region to region, the time of year. They're also even going to change, of course, during the day as the boundary layer begins to grow due to mixing and that sort of thing. And so you might have to adjust it even during the course of the day if you still want to see areas where you might have boundaries or moisture pooling that could be important for that day. So just here was a little example, and unfortunately at the time when I saved this, I had the set color table range box a little bit in the way. But anyway, what you can see here is the range of values. In this case, in this just default procedure I had were set to 6 and 1.5, which is, you know, kind of a standard in some situations. It just depends. But notice here when I change that to 4, 3, and 2, 9, so the max and min range values for that temperature difference. And then notice that in this particular case, that actually lines up a lot better with where I have low Q, cumulus developing. And so when I go back to here, it's not quite as evident. Unfortunately, the box is in the way for some of this, but then I go back here, and then again, you can see that a lot of places here, especially in southern and eastern Virginia and parts of North Carolina, where the Q are developing, fit a little bit better with that sort of range of values. So that's what I would tend to leave that on and then watch and see, if those areas might be ultimately favored for some sort of deeper convection. But of course, that depends on a lot of other environmental factors as well. And it's also important to take into account what is the particular convective forecasting challenge of the day, and does this help to resolve that? So, again, so the need to adjust brightness temperature ranges. So here, if I were just to look at the sort of the standard that's in there, it's the 15 and minus 15, and I apply it actually to my color map, it might not bring out these sort of boundaries or areas where moisture might be initially pooling, or you might get a little bit more enhanced mixing and then boundary layer growth during maybe some crucial hours in the morning. So here it looks somewhat homogeneous, certainly at least to my eyes. However, when adjusting, so here it was minus 15 to 15, and now I changed the color map range of values from 6 to 10, and I did that after I sampled around this area and saw, like, well, what sorts of values am I seeing in this area? What might it be best to set my range of values to maximize being able to see areas where something is indeed maybe prone to developing? And so as we go through this loop here, if you, I may have to go back here, actually. So if you kind of focus on this area, we're in this circle here, you start to notice that you do get some greens developing there, which might indicate, the development of some deeper moisture there, thus making this area, at least in this particular situation, perhaps more prone for some convective development. Now, some forecasters in this area may have some insight into this thing. I did look to make sure this wasn't necessarily terrain enhanced right there in that circle, and it didn't appear. But then notice that, that might have given you in this situation maybe just a little bit of a heads up, and maybe some increased confidence that, like, well, I'm starting to see, a little bit better boundary layer growth, some deeper moisture in this area. Perhaps this would be favored for convection. And indeed, that's what actually happened in this instance. This was just, I guess, a couple of days ago. So the need to adjust brightness temperature ranges, as I mentioned, may also occur even just during the day as you're getting, boundary layer growth and, with the onset of deeper mixing due to insolation. And so, again, I got kind of a simple little cartoonish graphic here that helps to illustrate this. And so, during the morning hours and before mixing, what you're going to have often is moisture pooling near the surface, especially in quiet environments where you don't have wind stirring things up, or some sort of advection or lifting processes. But if a lot of times, especially this time of year, if you're looking at the split window across a good portion of the CONUS, this time of year, the values are going to be very small because that moisture is pooling in the very low levels, and it may be somewhat homogeneous across an area. But then as the boundary layer growth begins, then all of a sudden you start to see this ballooning of values, and you'll see bright split window brightness temperature differences that will increase during the day. So here is, again, just a very recent case of this, and what you can see here in West Texas in this instance is indeed that sort of thing taking place. And so now you're getting mixing occur, and you're getting moisture that's now becoming more active in the lower level environment, and it's being spread vertically. And so then your differences between 12.3 and 10.3 micron are changing. So if you then wanted to see some tease out maybe some sorts of boundaries that are important in this area for this day, you might then have to go in and adjust that range of values. Same here in this situation. Again, you can tell recently I did a lot of this. I think it was yesterday in Florida. Notice here that again with the onset of mixing, notice that and boundary layer deepening, and now you're incorporating moisture, and spreading it out more vertically through the column, and so you get larger differences through the day. And so then maybe if you wanted to see if there were any sorts of important areas for pooling or convergence or that type of thing, you would then need to adjust those brightness temperature difference values again during the day. So, but once after you've sampled around an area and then you've come up with some sort of a good spread in values that helps you to tease out the locations of important boundaries. This is a type of imagery that you might get. And so notice in this area here, across parts of the Texas Panhandle and western Oklahoma, you can very clearly see this moisture boundary that is then draped southwest and northeast across the area. And this even all goes down, of course, to sub-county scales. And this thing might allow for some sort of more effective meso-analysis, maybe even IDSS, like, hey, we have good reason to believe this boundary is right across these areas, and thus, all else being equal and not any significant changes, this is where convection would occur, but we'll have to watch and see how this boundary evolves here during the day. Here was a case from just a little bit earlier this year, and I'll show a neat loop here in just a minute. But there was some pretty significant convection that occurred this day. I'm sure some of you are much more familiar with this event than I am, if you were out here in the plains. But anyway, so just to let you know the type of values you might see across an area, and then how you set the range. So when I was sampling across this area during the day, I knew that there was some sort of a boundary draped across the area, and they were anticipating convection roughly in portions of central eastern Kansas and central Oklahoma. So this bottom value that you see here, the 3.86, that's in relation to the brightness temperature difference between the 12.3 and 10.3 micron at that time out in this area where my little cursor is located. Sampling on the west side of it, something similar, about 3.98 Kelvin, but then right in the heart of that, it was 6.02 Kelvin. So again, right in that area where you see the green colors, there was some indication of moisture pooling or a moisture boundary right there. And thus here's a loop that shows that, well, indeed, and in fact, that is where the convection initiated. And even before you had a single cumulus cloud develop, you could see where was that most likely to occur. And if I had even maybe stretched those values and shrunk them, a little bit more, I might have even been able to tell almost exactly, maybe to the county level. But in this case, this is just the imagery I happen to save. So, but I certainly think that this loop here gets that point across about making sure you're adjusting values to try to find where, in fact, that moisture boundary is and where convection may be most likely to occur. This was another case. This is one I actually shared one of the meso-analysis chat rooms one day. My Sue just encouraged me to do so. I showed this, and and she was like, "Oh, you ought to share this in the meso-analysis." I was like, "Oh, okay, sure." So, but anyway, but here you can see, and what I'm wanting you to focus in on is this little green swath here that's cutting across northern Missouri and southeast Iowa, and then it goes on. It's a little bit broader, but in Illinois. But notice that even before any cumulus start to develop, you start to see. You can see certainly an area where there's moisture convergence or pooling there in northern Missouri and southeast Iowa, and then you start to get some Q develop. A little bit later, there's a little bit more Q development, and in fact, this is where some significant convection did end up occurring. I think it was mostly in Illinois, but in a little nod and thanks to TJ Turnage here, I didn't save any other imagery, and that's as late as I got that on that particular day. But anyway, I went back and grabbed these loops here, and then notice that in fact you can see the deep convection ending up developing right along where that moisture boundary was. I do also show the nighttime microphysics here. It's important to point out that the red color component of the nighttime microphysics RGB is the split window, although it's reversed. But anyway, I'll go into this just a little bit more detail in a minute. But in the nighttime microphysics RGB, areas of blue versus areas of pink and clear sky conditions, that indicates a moisture boundary is present. And your deeper moisture is typically in those areas that appear more bluish rather than pink. And that's right in those areas right there. So, you know, I know I have a number of examples from the plains because quite honestly, that's the easiest to see most often, where they have more stark contrasts often in low level moisture. But anyway, here was a case actually. I kind of lucked out again yesterday, just kind of looking around the country, seeing what I could find. Mother Nature helped me out a little bit here. But here you can clearly see a case here in Michigan where you have cool and you have dry advection, and not only you see the cumulus, but you also see the low level moisture conditions as indicated by the green here. And notice how that moisture is moving along generally in concert with the you know, the low level cloudiness, the cumulus, the stratocu that are in the area. And also notice how along it looks like the eastern side of Lake Michigan there, going into southwest Michigan, northern Indiana, you can see the gradual you know, it looks to me like some sort of cool advection off the lake there, and what that's ending up resulting in is more shallow moisture, and perhaps some sort of a little stable environment moving into that area right there, and it's causing a decrease in the moisture. So I thought this was an interesting little scene here as well. And notice that, you know, the Q are pretty much moving along in areas where you have a little bit higher and deeper moisture. I thought I'd look out west and saw what I could see yesterday. I don't often quite actually look out there, although this was kind of interesting, something that showed up yesterday. I noticed that here, you know, you can see that for the most part, where you're starting to get an increase in the depth of mixing and deeper moisture, that does coincide largely in areas where you do have some low-level cloudiness. And in fact, some deep convection ended up developing there in eastern Nevada and western Colorado. However, that could also be some sort of terrain effects there as well. I did also wonder about, and I don't know about this, and anybody has any information or insight into this, you can feel free to chime in, but the use of this for mixing heights, maybe in just a spatial relativistic sense. Since you do get some information about areas where at least you might have moisture mixed greater vertically, does that also coincide with mixing heights in some instances? And that could be something that's perhaps important for the West, but again, I don't have a whole lot of expertise with that. Oh, and I did actually also layer the cirrus on this one in this particular case, because in some of this imagery, it was a little bit difficult to determine, especially over there near the Nevada-Utah border, if I was looking at really just low-level moisture pooling, or if that was in fact cirrus. It seemed to be a little bit of both, but it was easier to see the cirrus in this case after now this is kind of interesting. I have looked at this a number of times, especially as we get a little bit more into the summer season. This becomes a little bit more important, especially for my own area, because that's where I'm typically looking. But I have seen these instances in other parts of the country as well, and I just happened to notice this yesterday. And so that's also incorporating potentially soil moisture into this, and then how that might help to, you know, result in differential heating, as in this case here in West Texas. So what you're observing here, notice the split window difference, brightness temperatures. You're experiencing the largest increase. I'm going to try to bring up this pointer again here across this area here in West Texas. And notice that my levels here are a little bit lower. So at least my moisture, it looks like in this area, is a little more shallow. So my thinking here, when I started to look at the soil moisture values, these areas look to me like they experienced the largest increases across areas where in fact there were dry soils, and so that's where heating and mixing might have been most effective or most efficient during this particular situation. And so if I then go to the next image, this is actually a relative soil moisture plot. And well, you know, I do work with NASA Sport, so this is a soil moisture imagery and data that we do provide. This is actually an AWIPS if you wanted it, but that corresponded very well with where you tended to get more efficient mixing was where you had these drier soils and areas right in here where you had wetter soils. That was more slow to develop. Now, unfortunately, I didn't, get other imagery from this later on this day, but this would have indicated potential boundaries, as you can see, not only here in the brightness temperature difference, but also in the soil moisture about maybe where you could have had some sort of convection develop. But again, that's, of course, just based on the other factors in the meteorology of the day, which you have to be aware of. So I did just want to mention real quickly again, and I know that Bill Line did this in his talk too, and I was really glad to see that, is that, in the nighttime microphysics RGB, the red color component of that is the split window, although it's reversed. So the nighttime microphysics, it's 12.3 minus 10.3. Now that's often going to give you negative values. And so what will end up happening, well, I'll go into this in the next slide, but is that if you have smaller values of red, so you're essentially taking red away from this scene here, well, the more red you take away, it's going to tend to appear more blue in this case. And up here, where you have a relatively drier mass, it's going to tend to be more pinkish type of colors. And so this sorts of contrast here that you see between the drier mass, and notice there's no clouds here, so it's more pinkish, and down here it's much more blue. So I have a drier mass, moist air mass, and I do have some sort of a boundary right in between those two. Now, this was a day when I was, this is, as you can see here, this is late July. This is several years ago. And again, this issue of trying to find boundaries in the Southeast can really be difficult sometimes in the summer season. But sometimes early morning use, and especially if we're lucky where we have some clear sky conditions, you might see little differences across the region in areas where you might tend to have moisture pooling. That's what I've done here in this case, is actually just outline one of those areas. And again, the areas where you have a little bit more blue you're going to have a little bit more moisture pooling versus those where it's a little bit more pink. And so let's see what happens here. So as we kind of go through the day, and I just have a few snapshots, you can tend to see where the cumulus, in fact, where the greatest growth was that day. And then in fact, a little bit later, where at least I had a little showers develop. But in the Southeast, sometimes even these little showers can be important or meaningful during the summer season. So in summary, it is a really good thing to sample the brightness temperature difference values across your area of interest. I might actually try to demonstrate this. This could be dangerous. I might try to show this real quick in a cloud instance I've got running, although it may have stopped. I'll go over there in just a minute and we'll see what we see. You're going to need to adjust the brightness temperature values accordingly, so that areas of moisture pooling or convergence or boundaries, those kinds of moisture related features that you're looking for, so that they may become visible. Sometimes, however, these features, really, they may not be very evident or may require very small brightness temperature ranges. In some environments, I've had to shrink it down to 1 or 1.5 C, in fact, to even see if I could determine areas where there might be something that's meaningful in the split window data. You can layer other data of interest. I didn't really show any of this, but modeled moisture and RHK, radar, et cetera. A lot of times I will, at least, and especially in the summer here, I'll have streamlines laid up over these that might also tell me areas where I have maybe low level convergence, and I look to see was there evidence of moisture pooling in those areas. That might help give me a little bit more confidence in the model solution, but also then if I do see that moisture pooling, well, then areas that may thus ultimately really be favored for convection, because not only do I have some thermodynamics, but also have some dynamical factors in that as well. You can use the nighttime microphysics RGB at night for help. You could even use the dust RGB. It actually has the same, the split window is the red color component of that. Although when I have looked at that, most of the time it seems like it's been a little bit more subtle to me, determining where the moisture boundary is. And, I would say just dig around in the data and encourage you to, if you're going to do meso-analysis and use this to do this, and, share your findings with your colleagues or your coworkers, or sit down and discuss what you're seeing and why you think you're seeing what you're seeing, and that sort of thing. So. And I would say thanks for your time. And So Bill, I had to at least throw one a sort of JPSS related image on here. And yesterday, I was able to at least pull up, here's day-night band image and put that with the split window difference. Unfortunately, this wasn't a situation where I really got to see much, too much interest in here. And I think a lot of these light greens we're seeing actually are in cirrus clouds. But anyway, there very well could be and would likely be some situations where it could be interesting to actually view these together at night. And I do personally just like the visible imagery laid on with the split window. So with that, here's my email. You can always feel free to reach out to me with any questions, suggestions, thoughts, etc. I don't know everything about all this imagery. This is something, maybe a little bit of a pet project of mine. I've been looking at this deeper in other parts of the country, but also just trying to really sometimes figure out where might important boundaries be around my area. Often here in our part of the country, we have a lot of mid and high level clouds that can limit that, but if you have clear enough sky conditions, it can be interesting and potentially useful. So I don't know if I should try to open my cloud instance here real quick. Well, of course I got to log in, so let me just do this real quick and we'll see what we see in here.
Well, I'll tell you what, why don't, Kris, why don't I give a few things here and while you're doing that, and we'll go from there. So the check's in the mail for the little love you showed, the day-night band. Hopefully folks will be using that. I'd like to encourage folks to stay on for a discussion, especially the field office and regional headquarters representatives. You can certainly change your view if you go up and at the top of the where the camera is, you can view active cameras so that the people who are talking will show up if you so desire. Also, there's a link for feedback on this session, a short survey in the chat, so I encourage you to use that. A week from today on Thursday, June 6th, at noon Eastern, Evan Thomas, from the NASA Wallops flight facility, he's a range meteorologist there, will discuss the 3D launch weather analysis tool. Also, we just encourage you to contact the Tower S team, Rashad Bowman and Emily Maddox, for questions about the Satellite Book Club, and for any kind of input or questions you have on satellite products. They're going to help you through that. So with that, were you successful, Kris, in pulling up what you were hoping to show?
Yeah, I think so. Can you see my screen here? And what you're probably looking at is my, whoops, actually, let me go back again here.
Yep, we see it. Go ahead.
Okay. Yeah, I'll just do this real quick because I know in the interest of time, we probably need to get moving. But so here's my color map with just the standard, -15 to 15 color value range. So, immediately I could see some differences in browns and greens across this area, and there's probably some sort of a moisture boundary. This could be dry line over here in this area. So if I wanted to just sort of try to figure out, well, how might I better refine this? What I would do is a sample across the area, and you'll see over here, as I'm looking over here, I see values as low as well below 1K in this instance. And then when I go over to the moisture areas, it looks like values even up around 6 or so. So what I might want to do is just go in here, right click on my product, change the color map, and then, maybe look for values somewhere around, let's just try 1 to 6 and see what we see. And so then it might just be a little bit easier to determine where I might have a little bit more meaningful moisture pooling, or where might that boundary in fact be. And of course, it might even be good in here to play around with these values a little more. But that's just the type of thing that you do, that I always do when I'm opening up the split window. I'm always going around and changing the value ranges to help me really see these boundaries a little bit better. That's just a quick demonstration of that, and that was all.
All right, super. So you have a couple of questions in the chat. Scott, you want to come off and just ask them or provide your input, and then to Kris?
Sure, I can do that. I hope you can hear me.
Yeah, we can hear you fine, Scott.
Okay. Yeah, we were looking at this a lot last week at HWT, this split window difference. And one of the things, you talk about the deepening moisture layer, and I think another way of thinking about that is the steepening lapse rate. So as you're getting closer and closer to dry adiabatic, the split window difference has a nicer and nicer signal. And your case over Southwest Michigan, where the cold wind came off the lake, and the split window difference suddenly didn't have such a great signal, I think that's a great example of that. And I also want to say that I know this is a split window difference talk, but don't forget about the level 2 products that are showing you similar things like the TPW and the CAPE. But I thought this was really great. Thanks, Kris.
Oh yeah, no, yeah, I would, yeah. I mean, sometimes I'll layer so many products on top of products, cave crashes. But yeah, it's it's a good idea. You can put onto the onto the D2D pane, whatever you want. So yeah, I would encourage other sorts of moisture data and products, and even GOES CAPE, new caps, CAPE values, all these sorts of things. It's it can be important to just know the challenge and the environment of that day and what's probably the most effective products to layer. And that can sometimes be a difficult thing to know, but I just wanted to start out with some basics here. Just basically focusing on the split window. But yeah, thanks, Scott. And I'm sure you got lots of great blog posts about this over on the Sims blog. So feel free to provide your own plug there and some links if you want.
So we also have some input from Doug Kahn. Are you there, Doug? Come off mute if you want. Okay, I'm not hearing you, Doug. He says, great talk, Kris. I wanted to start utilizing this at our office. I'm wondering if you see similar moisture gradients develop for lake effect snow across the Great Lakes. How can we access your color curve? And could you explain how you layered the 2 bands? Did you just decrease the alpha?
Yeah, so, oh wow. So it's lake effect snow events. I imagine you might see something. That's not really something I've done. I would encourage you to do so. That could be really interesting. If you have any sorts of images you want to share with me, please do. Although Scott may have something. Dan Bykos may have something. In fact, I think I saw a talk where Dan Bykos encourages people to do what I just did and change these values as needed from day to day or even during the day at times. As far as the color map, yeah, I did make those available to Kashad. Just one of the color maps that I have here, and you're always going to adjust the values anyway, so it doesn't matter really what you're kind of starting out with the values. You're probably going to have to play around with those, but at least it is just the basic color curve. And also there was a simple procedure that I provided them. And as far as the layering, yes, it's just decreasing the alpha. So what I do is I start out with a split window, and then the red vis is layered on top of that. I usually have it set, I think, somewhere around 75 or 80%. And then any other bands on top of that, especially if there's deep convection involved, I'll have the 10.3 micron on there. And I think I typically layer it to about 25%. And if sometimes I have really thin cirrus and it's not clear to me if I'm looking at cirrus or if I'm looking straight down at the surface, then I'll just toggle off and on the 138 micron band or layer it on top as well and set it to about 25% alpha. So.
Okay, very good. And Doug responded saying he's in ops, so he's just in listening only mode. So hopefully, I'll just encourage you, Doug, to give Kris a email if you need any further clarification. And Scott acknowledged that Bill Line has a lot of great split window channel examples in the satellite liaison blog. Scott, maybe you can put that link to his blog in the chat as well. Since we have maybe a minute or two for another one, the question that I had, Kris, was did you see any issues as you go edge scan on some of these things with the split window, whether it's deciding to use the east or use the west or what?
Yeah, as far as using east versus west, I don't know if I have a really good answer there. I mean, of course I'm almost always looking at it goes east for my own area. The imagery that I did show from Nevada, I did actually use goes 18 for that, and the procedures that I provided, if anybody wanted to use those, I did provide them from both satellites. So they can feel free to use whichever one they wish there. Did that answer your question, Bill?
Well, the thought I had is you're looking sometimes at such a phenomenon at such a small level or small scale that edge scan may cause some issues if you see that small scale feature suddenly move abnormally.
Right. I don't know if I've observed that. At least the good thing with this imagery is that you're looking pretty low level, so I guess that minimizes to some extent the parallax. But yeah, it's still important to know that the parallax is there, and it might need to be shifted just a little bit, especially as I showed an example or two where you could really see the moisture boundary, sub-county scale level. You might want to pay special attention to that and think about that. It's like, well, it could be just, perhaps a little bit southeast of there or south, west of there, whatever whichever satellite you're using in that particular situation. But yeah, that's something to think about and pay attention to, especially, yeah, when you're drilling down to these, very small scale features.
Yeah, and the other thought is it may be, is there a good split window channel training guide that you can reference?
I've come across some things out there. I know that I think Scott Lindstrom has some things to share. I did come across a video that Dan Bicus had done in association with the split window and using it and ways to use it effectively. I think he touches on some of these things as well. And so just in my own experience, I wanted to just present this to a wider audience too. So I can't remember exactly, but it's one of the trainings. It's a visit view, sort of a module done by Dan Bicus there. I think he's with CIRA. And so you could just probably Google that and come up with that training.
Hey, well, very good. We're running overtime, perhaps. I don't want to make Kashan give me the hook, but oh, there it is. There's a quick guide that Scott just put into the chat. Yeah.
Okay,
so
great.
Those
Thanks, Scott.
things that get rolled up. So I think, Brian, I'll turn it back over to you for any last thoughts.
All right. Hey, Bill, thanks so much. I know you had your hands full today. Really appreciate you facilitating. And Kris, also great presentation. I learned a lot about the split window, a lot of subtleties to watch out for that I was unaware of, and I'm sure others took a lot away from this as well. So we really appreciate it. As Bill let us know a little earlier, please join us a week from today for the usual date time satellite book club. Next Thursday, we've got Evan Thomas's presentation, 3D launch weather analysis tool. So we will see you then. Until now, thanks for your participation, both those joining, the organizers. And with that, we'll wrap up today's book club.